Hello, Innovation Academy. Welcome to the at-home version of the Westerville Public Library monthly Innovation Academy programs. I am one of your youth librarians, Annamarie, and I am so excited to be bringing this in-library program experience to all of you at home virtually. A little bit of background for anyone joining us for the first time. I started the Innovation Academy series about 3 years ago. At the time, it was designed for ages 8 to 11 with a focus on technology. Over the last year, the program evolved into all kinds of learning, still teaching some of those tech skills, but also including art projects, finger knitting, engineering concepts, and more. Now, we are bringing that in-library program experience to you at home. First, we are expanding the intended age range of this series to include ages 6 to 11. Really, there is some version of these activities that can work for just about any age or reading ability. So if you are at home with younger siblings, older siblings, grandparents, and grown-ups of all ages, invite them to join in. Innovation Academy projects thrive on teamwork and bouncing ideas off of others, so the more the merrier. Second, to distinguish this series from some of our other great virtual program offerings, we will be focusing on technology that you can explore from home. You don't need any special robots, but you will need a device that can connect to the internet, which, if you are watching this video, you probably have. Third, each program will focus on a different topic and will include specially selected resources for all skill levels. You are welcome to watch this intro to get an overview of what you will be exploring, or you can move straight to the included PDFs, which will include written instructions as well as links to all of those great online resources. Finally, did you create something cool? Have a great time playing one of the shared games? Really didn't enjoy this month's content? Share that with us. We create content and programs based on your feedback, and we often alter our programs based on your reactions. I can't see you through my computer screen, but I do want to provide the best programs we can. Please send along your feedback. All right, that was a rather lengthy introduction, and you have all been so patient. It is time to jump into this session's topic, coding. We are going to start by getting some of that vocabulary out of the way. So first, a code, also known as a program, is a list of steps or commands designed to be carried out by a computer. Coding or programming is the art of creating a list of steps to finish a task. So, when you are coding, you are writing a set of instructions designed to be carried out by a computer. To learn how to write code, you need to understand the coding language the computer you are coding speaks. There are many coding languages. Some popular ones include Java, Python, and C. There are many different ways to break down coding and coding languages, but to make this easy to understand for our brand new coders, we will be talking about 3 types of coding in this program: unplugged coding, block-based coding, and text-based coding. Unplugged coding involves no technology. You aren't focusing on coding a real computer yet. Normally, you are coding another person. You are practicing computational thinking skills and learning to think like a coder, particularly focusing on very specific, clear, detailed instructions, often to complete simple everyday tasks. These activities can be fun for all experience levels, but are ideal for pre-readers, beginning readers, and everyone completely new to coding. Block-based coding involves connecting blocks of text or images together to create a set of instructions for a computer to follow. These can be long, detailed strings of code with repeats, conditional statements, and more, or they can be as simple as connecting directional arrows to move a virtual character from one point to another. Block-based coding is a great way to think like a coder while completing real tasks and creating real programs without having to master the details of a programming language or worrying about mistyping a comma as a semicolon. Block-based coding is often ideal for readers, but some apps and websites focus on just directional coding that uses images, allowing pre-readers and beginning readers to join in. Text-based coding is what most people think of when they talk about coding. These are the real coding languages that programmers use to make computers, software, and websites work. If you are new to text-based coding, learning Python is a great place to start. There are great tutorials out there, including many available in the intermediate and advanced sections of the included packet. Text-based coding requires reading skills, attention to detail, and the patience to sit in front of a computer for a few hours. Things like punctuation and exact spelling are very important. Coding is not an exact science. Real coders spend most of their time finding errors in their code and working to fix problems. No one expects any code to work exactly right the first time. In coding, these errors in a program are called bugs. They prevent a program from running as expected. Coders spend a lot of their time debugging programs, finding and fixing errors they or other programmers made or didn't expect. Again, coding is a process of trial and error. If something isn't working, try something new. Talk it out. Find someone to help you get to a new idea. The rest of the PDF packet that you have received includes ideas and resources for all levels of coding experience. I'm going to highlight a few of my favorites over the next few slides, but don't worry if you are already familiar with all of these. There are a ton of great resources in that packet. First, two of my favorite unplugged coding activities. The first is one of the best ways to wrap your head around what coding is and how to think like a coder. You need at least two people and a regular household task. This can be folding the laundry, making a bed, or making a sandwich. Make sure to check with an adult before you start any of these activities. One person acts as the programmer. That person instructs the second person, the computer, on how to complete the task. The programmer needs to be very specific. The computer cannot ask any questions and has to do exactly what they are told. However, the computer can interpret vague instructions however they would like. For example, open the bread does not specify how the bag should be opened. This activity teaches the need to be specific and to really think through each direction. Another one of my favorite unplugged activities is the if-then backyard coding game. This can involve any number of people and is great for all ages, including preschoolers. Similar to a game of Simon Says, most people playing, the computers, must follow the instructions of the leader or programmer. The programmer may say, if I turn around, then you turn around, a relatively simple instruction. However, this can be more complicated as the statements evolve. For example, a programmer could say, if I raise my arms, then you stand on one foot. Else, jump up and down. If the programmer does nothing, all of the computers should be jumping up and down. When it comes to beginning to code with a computer, the go-to resource for all ages is Hour of Code at code.org. This provides a variety of games meant to take just 1 hour to complete. Some are designed for pre-readers, others use block-based coding, more ideal for older participants. Many activities feature favorite characters from Minecraft, Frozen, Star Wars, Angry Birds, and more. In addition to Hour of Code, there are a ton of great free apps available. For particularly early coders, especially pre- and beginning readers, Think and Learn Codapillar and Scratch Junior are some great options available across all types of devices. Moving on to our intermediate coders. This category can include folks with experience coding at school or home, and also older learners who quickly grasp coding concepts and want to dive into something more complicated. There are 2 full pages of resources in our packet that range from block-based coding like Scratch to text-based coding tutorials and ways to learn to code your own apps. Scratch, visible on your screen right now, is the gold standard of free, open-ended, block-based coding websites. Even if you have used Scratch in the past, I suggest revisiting. The Scratch 3.0 update includes more ways to create and share your programs, more tutorials for first-time users, and special features like integrated Google Translate. If you are looking for something different and are ready to move beyond Scratch, but you aren't quite ready for some of the advanced text-based coding courses, check out Code Combat. This is a fully immersive computer game that teaches real coding languages using JavaScript and Python through project-based games that can be played individually or as a group. Our advanced coding resources are going to exclusively focus on text-based coding. Some will provide beginning overviews and tutorials of your chosen coding languages. Others will expect you to have some experience with that language. These advanced resources are some of the same training tools that adults who are professional coders use to learn languages. Codecademy is a great place to start if you want to see if text-based coding and our advanced resources are for you. They have many, many excellent free courses. Just make sure that you are looking at the free tracks and not the pro tracks. I hope you are all ready to dive into some fantastic coding experiences. As a reminder, your Westerville Library librarians are working hard making our services available to you virtually. With your library card, you can check out a ton of great ebooks, e-audiobooks, music, and movies. If you don't have a card or your card isn't working, just send us an email. We also have many virtual programs, including 5 virtual story times a week designed for ages 0 to 6, our virtual Learn at Home program, Read and Explore, where you can earn virtual badges for various projects, and additional school-age virtual programs, including Young Engineers, Art Lab, and Innovation Academy, all of which will be continuing through May. Plus, we are available to answer your questions through email, chat, or any of our social media pages. Thank you all for listening. I'm wishing you all the best in these very interesting times. This was Annamarie, one of your Westerville Library Youth Librarians. My contact information is on the screen as well as in the email that you received this video in. Please reach out if you have any questions or just would like to share some of the awesome things you are doing at home. We miss you guys too. Good luck and happy coding!